Video, we're just going to review the basic types of factoring. We have GCF, quadratics, bottoms up, and difference of squares. So let's look at our first problem. So the first thing I'm going to notice is it doesn't have three terms, so it's not going to be quadratic or bottoms up. So the next thing, is it a difference of two squares? It's not. So it's going to be GCF. So let's look at our number part. So our greatest common factor of 6 and 3 is 3. And our greatest common factor of n to the third and n to the fifth is n to the third. So when I take that out, 6 divided by 3 is 2. N to the third divided by n to the third is 1. Minus 3 divided by 3 is 1. And n to the fifth divided by n to the third is n squared. So we have three terms, so it could be quadratic. But we're going to go through our list first. We're going to start with GCF. So does it have a GCF? Yes. So my number part has a GCF of 7. My variable part has a GCF of A. I can't take out more A's than I have in every single term, and I have 1, 2, and 3. So 14 divided by 7 is 2. A divided by A is 1. Plus 21 divided by 7 is 3. A squared divided by 1A is A. Plus 21 divided by 7 is 3. And A cubed divided by A is A squared. So, does it have a GCF? No, there's no GCF. Is it a difference of two perfect squares? No. So my next option is quadratic. So remember, with a quadratic, we have an x and an x. Now our signs of our values have to multiply to be the last and add to be the middle. Well, I can only get a positive two ways, either a positive times a positive or a negative times a negative. So which of these is going to add to be a negative? Well, that would be a negative. So I have two negatives. So then we have to figure out what two numbers will multiply to be 64 and add to be 16. So that's going to be 8 and 8. 8 times 8 is 64, and negative 8 plus negative 8 is negative 16. So the first thing I want to check for is a GCF, and they do have a GCF. There's a GCF of 4 and a GCF of A. So I'm going to have 4A. 4A cubed divided by 4A is A squared. 8A cubed divided by 4A is 2A. Plus 4A divided by itself is 1. So then we have to start the process over for this portion of our factor. Does it have a GCF? Well, no. If it did, that means you didn't take out a big enough GCF the first time. So is it a difference of two squares? Obviously not, meaning quadratic. So we have 4A, and I'm going to have an A and an A. Again, we're looking for a positive, so it either has to be two positives or two negatives. With my center term being positive, I know I'm dealing with two positives. And there's only one factor of 1. And 1 plus 1 is 2. So we have our next quadratic. So again, not a difference of squares, not a GCF. So I'm going to have an x and an x. My two signs have to multiply to be positive, add to be negatives. That's two negatives. And I'm looking for the factors of 36 that will add to be 13. So I have 1 and 36. 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So I'm looking at these two numbers and seeing which set of two numbers could add to be 13. And that's right there, 9 and 4. And I'm done. So we have another trinomial. Does it have a GCF? No. Is it a difference of two squares? No. Can I use quadratic? Yes, but I'm going to use the bottoms up method. So I'm going to give the coefficient of the leading term to the last term by multiplication. So I have a squared minus 11a plus 28. So we're going to go through our process again. The factors of 28 that add to be 11. So we have 1 and 28, 2 and 14, 4 and 7, and that's it. So I'm looking for the two things that are going to add to be 11. That's going to be 4 and 7. So I have A minus 4 and a minus 7. But I'm not done because I multiplied by 7. I've got to take that 7 back out, so I'm going to divide by 7. So 4 over 7 doesn't reduce, but 7 over 7 does, to 1. Now because this still has a bottom, we're going to bring it back up as a coefficient. That's going to give me 7a minus 4 and a minus 1. Now you can always check with bottoms up. Well, with any factoring method, you should be able to multiply your factors and get back your